So what we have up here is actually the current architecture of CloudStack. Our agent manager down here is our messaging and bus, basically. And we talk to a bunch of resources that we write to talk to all the physical resources. And above are controlled by different managers. They all have their own processes and that they install. And at the very top is our web services API layer. So we are actually, since our 2.2 release, we have been actively moving to this type of architecture because we believe there would be a lot of people who needs to come in and make changes to CloudStack to add functionality, to add capabilities, and we put in APIs for people to segment different portions of CloudStack so that they know where to add. So let me go into that a little bit. From the bottom up, once again, these are our resources, and in CloudStack's terms, our resources are basically our interfaces to the actual physical hardware. So for each different type of physical hardware, there are different resources. We will have a VMware resource. There's also a SAN server resource, and even for different versions of SAN server, there are different resources just to handle the minute details from version to version. And to talk to the resources, the management server always goes through a in the original version is our agent manager. Here, what we're trying to convey is that the agent manager's communication mechanism can be a message bus, and it is today. I think in Sherdeep's presentation, you saw the resource for KVM, the resource for OVM actually runs in a JVM that is deployed remotely from the management server, and their communication is done all through JSON. So our agent API at this level is all JSON, and it will take a little bit getting used to because a lot of our code still says is Java, but at the end they all translate into JSON before it goes down to the resource. Above that, there's a set of core functionalities that the management server provides. Things like being able to cluster the management servers, provide different nodes in that cluster so you can scale out the management server to handle different loads. Our resource management, which handles the connections to the resource, how to send messages to the resource, detecting whether a resource has dropped out or come into management. There's the job management, which is the async job queue. There's alert and event management, and then there's database access. And all these things are all layers so that the top portion of our code, where majority of our business logic do not actually have to understand underneath. So it is possible to swap the infrastructure out without affecting what is above us. Now then, and it comes to in CloudStack, then you need to look at, well, what does CloudStack actually does? A lot of the things that CloudStack does, it would be in this kernel, which actually does a lot of our orchestration pieces. And this is important to segment out because modifications in here is tricky at best, because you are actually talking to physical resources. There are a lot of problems on whether or not the operation would time out, whether or not the operation succeeded, exactly how do you even get that operation to work on that particular resource, and things like that. So in our kernel, it's all about how to orchestrate the VM operations, how to orchestrate volume movement, and things like that inside this kernel. And we put around it our services API to make it so that people who wants to use the operations we already defined can just use it without thinking about it. And other people can add code into CloudStack by by adding features that might operate on the database, might operate on other things without having to think about this particular piece. And then we also have what we call the plugin architecture. Our plugins are really two different parts. It depends on what you want to modify in CloudStack. Plugins are for changing behavior in CloudStack and adding capabilities into CloudStack, right? So we have interfaces that we define, and that says, in order to modify this behavior, you have to implement something. And these are the at this point the plugins that you can add in. And I have a slide later that talks about how these are structured. And over here then is really the assistance or services that you can actually provide. And a lot of these current CloudStack code provides certain services. For example, HA, where HA plugs into the kernel and says, well, I really want to just monitor if a VM has gone away, a VM has died, and then once I see that it's gone, I'm gonna work as an admin to restart the VM, and I won't work in a special way such that I have some secret APIs or something like that you can go through, but instead he's really just helping run operations for the administrator. So a lot of people can actually add code here in this portion that says, I want this particular behavior, or I want this particular monitoring of CloudStack or the VMs underneath, and I just want to be able to drive that through this API. And above here is still basically our REST API, and you will be able to add in different. We have architecture such that you can add in different types of API or different compliances to other API structures above, and still map it to underneath to CloudStack. And here would be our ACL and checks before someone is able to use it. Is there any questions about this? Or was that? Yes. Can you use the mic?
Is there transactional semantics around configuring multiple resources in response to a request?
Sorry, I still can.
Do you have a concept of transactional semantics when you're configuring multiple resources in response to a request?
Yeah, so when you're configuring, we actually do not allow transaction semantics across the resources because the underneath hardware is not, a lot of them do not have that type of semantics. So what we want to make sure of is that when you're implementing a certain resource, the operations that it carry out has to be idempotent, and it has to be a repeatable operations. And CloudStack would retry operations for you if something fails, but we do not go, I'm going to go roll back all these, or you cannot throw an exception inside that and have it roll back.
Hello, question on roughly how are all of these in user space code, the plugins and all of those things, and the kernel piece is also in user space?
Yeah, kernel might be a confusing term. It is not an OS kernel. This is the CloudStack kernel, and the whole thing is in user space. This is all Java code at this point. What we mean by kernel is that when you go look at the operations that needs to be run, and these are the ones that actually have to talk to the resource and orchestrate the resource operations. So, okay. So basically, this is our definition of the kernel module. It knows how to orchestrate long-running processes because when you talk to a resource, it may take up to minutes. It may take up to it may never return. I mean that's happened to us quite often. And you have to be able to time out, have to be able to orchestrate those type of operations, and that's what kernel module do. And there's people who likes to work in that that area, and there's people who wouldn't. And kernel module exposes it so that people who doesn't want to work in that area can actually still can add functionalities into CloudStack without understanding these processes. And basically inside the kernel module, to configure how the kernel works, we have our plugin API to execute those functions. For plugins, like I said, there's various ways to add capability to CloudStack. Now, they each have their own interface, and all operations must be idempotent. Once we call the plugin, and at that end, we check to make sure that there are no database transactions that you can reverse. So from there on, it is up to you to make sure every information that we send to you is persisted, that you can repeat them, and things like that. All right. And we make sure that the plugin and modules should only compile against our API module, which only contains the interfaces to clearly, so that we don't have any crossovers between that code boundaries. So what exactly is a plugin? I think if you take a look at have looked at our Confluence website, you might have run across like 101 where we talk about our adapters and things like that. And I kind of want to show what is a plugin. And a plugin is basically a package of two sets of jars. One set will go into CloudStack to help run the business logic. One set will go into a resource that may run co-located with the hardware, because I think as Sherry mentioned, CloudStack clearly defines what is control path and what is data path, and a lot of the work that needs to be done inside the data center, close to the hardware, needs to be co-located with that hardware. And management server is just not there. So our management server cannot be in that portion. And the business logic, though, runs within CloudStack's management server. And when we look at the plugin API, there's actually multiple sets of APIs here. And there's actually another slide that tells you where you can make the modifications. And so one plugin may actually implement several functions because you're actually implementing several features. Yeah, that's basically just goes over. And as an example, so one thing I kind of want to go through is our OVS plugin. OVS is our implementation of SDN, and and what it actually have to implement is two different interfaces. There's the network guru, because in CloudStack, the network guru defines our network. It understands how to segment the network. It understands how to issue what are the IP addresses that needs to be issued. If it's IPv6 IP addresses, it can be issued there, right? So someone can actually add in that type of functionality into CloudStack. But then at the same time, it also is a network element because SDN means that the paths are configured, and we statically configure them on the hypervisor. So as a VM is started and things like that, then we inform the network element and says, oh, this VM is being started. This was the IP address that was issued to it from the network guru, and here's the MAC address and things of that nature. And now you have to go program it. And the network element can actually do that work and do the programming. So these are the things that are available today to implement specific functionalities that CloudStack needs. As I said, a network guru implements the network isolation. It understands what is the physical network and how to do isolation on that physical network, and what are the IP addresses that can be used and issued. A network element and helps with the network services available to the VMs. things like DNS, DHCP, load balancing, VPN, port forwarding, and there's actually much more. And so, for example, our NetScaler would be implemented as a network element, and that only supports load balancing today. And more features can be added on top of that. We also have the idea of a deployment planner, where people have different ideas where a VM should be deployed and its volume should be created. And for HA also has its own plugins where people can write in code that says, oh, in order to see whether or not a VM is down or not, you need to, I can do this for you. Because we may not completely understand the technology deployed in the data center to investigate whether or not a VM has gone down or not. And being able to fence if a VM, fence off the VM from accessing the network and hardware and disk before we can restart it. So we have these sets of plugins where you can actually write. And quite a few of them would not have resources. So for example, a deployment planner may not have resources that it needs to, that needs to be deployed, and it's purely a management server plugin. But you can write that. For example, if you were plugging into some sort of a workload engine that only deploy inside a data center, then you might have a resource that runs co-located with that workload engine, and then there's a small piece on management server that contacts that resource. Is there any questions regarding this? Yeah.
So I have a question. So if you have extending some of the network offerings through the plugins, do we have to do anything extra in terms of these services being available from the existing UI, or are there any UI extension points?
So today we do not have a pluggable UI where these things can actually expose its own UI. We do have a way for you to plug in a web services API, but the UI you will have to actually modify. So there are entry points to configure the things that you want to add, but there's no UI today. And it's on a roadmap to actually add something like that. The two things that's missing in the plugin and interface, I think, is one is this pluggable UI. The other one is a way for it to update its schema independent of CloudStack, because whatever code you have may have its own database schema. Can you
Yeah. What is a host allocator does?
Okay, yeah.
Can be more
that's a good
specific?
question.
Sorry.
So host allocators are ways to find which host to deploy the VM on. Deployment planner is different. Deployment planner is a heuristics-based algorithm. But then, once you went through went past the heuristics, then there's also physical attributes that you have to consider. So, for example, if you are deploying on VMware, it reserves a certain set of resources that says, "Oh, you cannot deploy it here because I have to reserve enough for HA." Hey. So there's algorithms that needs to take that into consideration when it's a VMware hypervisor, or when you're doing SenServer, something similar. Each VM there might be overhead for memory, so the VM may take 1 gig, but then there's actually another 200 megabytes of memory that SenServer adds onto each VM because it needs that to do mapping and things like that. So each host allocator are things that gives you that capability, depending on what hypervisor. And so then, and this question also goes back to this, because when we look at the difference between a plugin, a server resource, and an adapter. This is what we're talking about, because as a server resource, the server resource that talks to the sensitive hypervisor, you will write a server resource, but then you will also write a host allocator because it has a specific different way of allocating to its host, determining whether or not a host can actually deploy that VM. So then a plugins would contain both of these in that case.
Can you hear me? Okay. If you want to do something like affinity rules or anti-affinity rules, which of these plugins would you customize?
Yeah, so the affinity rules and anti-affinity rules would be in the deployment planner, because to us it would be heuristics and these type of rules inside there.
So if you wanted to say that a pod is a failure domain, and I wanted to deploy VMs so that no two VMs are in the same pod,
Right.
then I could do some custom algorithm like that.
Right, and actually we have that for a customer today. When we first started, we thought the idea of VMs must be that users want their VMs concentrated close to each other, because then, or at least administrators would want that, because then you can take advantage of the network locality, right? So that it doesn't go over a core switch. But turns out, depending on your deployment, we have users that comes back and says, oh, what we're doing is Hadoop instances, and what we really want is them spread across failure boundaries instead of being concentrated. And we've written deployment planners that does exactly that. We spread them across all pods and clusters before it gets repeated. Yeah, Dave?
So it appears that host allocator and deployment planner are very closely related. Can you tell us, first of all, which gets processed first and what the dividing line between the two is?
Right. So deployment planner gets called first. Deployment planner gives you, according to the heuristics, which set of clusters you want to deploy to, and from there, then we go through each host allocator and says, for this cluster, pick me a host, things like that. And same thing with the storage pool allocators.
So host allocator is cluster specific then?
Well,
Or
host
rather,
allocator,
host allocator is only going to make decisions once a cluster has been selected by the deployment
That's right.
planner.
So to add a plugin into CloudStack is fairly straightforward. When we looked at CloudStack before, we've always expected CloudStack to be deployed in an environment where we're not sure what the technology is, where we may not completely understand every single technology inside. So we had originally had thought that there's a lot of professional services involved in deploying CloudStack, where we come up with a switch that we don't understand or a router that we don't understand. Someone has to write that type of code. And so then we put how we put together CloudStack in this components.xml. And I think I have an example. So in this components.xml, there would be a set of adapters, for example, and this is for the storage pool adapter that says, well, to run CloudStack, we're going to run it with two different types of allocators for storage pool, and there's a bunch of other things, and so that people can and look at it and says, well, if I have no local storage, then I don't even want to deploy this adapter, or if I don't want on first fit storage, I only want on the user dispersing and storage pool allocators. So that's all controlled by this components.xml. And then when CloudStack starts, then CloudStack will load all that appropriately. And as part of, that is part of CloudStack, the product, right? And as part of this move over to open source, then we look at it as CloudStack, how CloudStack should function as a platform. And components.xml today is our homegrown product. And we're looking at possibly converting over to some sort of a different type of component framework to do these things. And we welcome any contributions or ideas in what framework to use. One of the things that we're looking at is OSGI, which has been famously used by Eclipse as a way to modify Eclipse's capabilities. And I think we can apply that to CloudStack. Now, I want to specifically point out this pluggable service definition. And so the pluggable service definition is a way for the elements to, for the adapters to expose API that would be executed through CloudStack. So when you put that in, and our CloudStack will actually go through and locate all of the commands that is being exposed by this service, and the same REST API can be used to execute things inside that.
Can I ask a question? So we use standard dependency injection to wire the components together?
Yeah, so we actually use CGlib, yeah. In here, what we do is we define the implementations, and then in CloudStack we use CGlib to put them together by. All you have to say is, all I want is this particular interface, this particular manager, and the implementation is provided for you when your class is instantiated. So this is kind of a sequence flow for deploy VM. Now, deploy VM would be an operation within the kernel because it involves orchestrating a huge set of resources. And I wanted to show that to show where are the things that the kernel had put out to expect people to make changes. Now, everything in orange here would be basically an adapter or a plugin. And then the rest is kind of our code that's existing in CloudStack. So when a deploy VM request comes in, and the first thing that will happen is we do ACL checks, and we send these objects over to adapters called security checkers that allows you to check whether or not the end user, the caller is a administrator, or if it's an end user. If it's end user, it goes through a different set of security checks to make sure that that end user is the owner of every object that's there. And if it's an administrator, then we check to make sure that administrator is the domain admin for that end user and has the ability to make changes to that end user's system. And then we allocate entities inside CloudStack. That basically that's us creating entities in our database to represent that particular operation, where we allocate the VM, and virtual manager would then says, okay, I allocated the VM. Somebody else needs to take care of how to allocate the NIC. When we take care of allocating the NIC, the network manager then goes to the network guru and says, I have this NIC going to be deployed in your network. You're the network guru responsible for that network. Give me an IP for which the VM can start. And once that's been done, then we also go to storage and says allocate a volume in the database, make sure our things are okay, and then we schedule the job into the async queue. So I don't have Share Deep's PowerPoint here, and so that would be the job between our REST API and the kernel. And we schedule that, and then we return back and says, okay, here's the job ID, and here's the VM ID. And the caller from there on will query the job results. They can also go and call get VM on the ID and see what its current status is. But to see if the deploy job itself has finished, then they just keep querying with the job ID.
Does that workflow change when you're adding LDAP off?
Yeah, so the LDAP off would be one of these security checkers. Would be a special implementation for that security checker. So the process itself doesn't change, but who you're talking to make that authentication is implemented by the adapters. Yes?
Yeah, is each of the allocate steps a separate transaction, or what actually gets committed to the
So
database?
at this point, we actually, this one is part of the same transaction because here there is no resource being contacted. It's merely creating the objects in CloudStack so that we can represent and properly what is the current state of the system.
When is the object created?
When we call these allocate VMs. Here, there's no operations to the resources. Yeah, that's the next slide. So I mean, if you notice here, there's actually, it's not executed by a job thread. It's actually executed by the Tomcat request thread at this point. So now then, and we have a set of thread queues in each management server. Once that job has been scheduled here, then the management server will pick it up and deliver it to one of our job threads. And the job thread then says, oh, this is a deploy VM. We already have all of the objects created in our database. I'm going to start the execution process to get it started on the resource. So we inform the user VM manager. This is a user VM. If it was a .mar, we would have informed the virtual router manager or one of our system VM managers. And then that manager says, okay, I prepare everything I need to prepare for that user VM. I'm going to call the generic code to start all VMs. And it calls in our code, that's the virtual machine manager. Calls to start VM. Virtual machine manager then talks to the deployment planner and says, I got to start a VM. You got to give me the host and the storage pool that's required. And here, actually, deployment planner would then also talk to the host allocator. But that's a little much detail, so I didn't put it in. It actually would talk to the host allocator to find a host, talk to the storage pool allocator to find a storage pool to place the volumes, returns back. And then the virtual machine manager then talks to the network manager and says, okay, here's the destination that this VM is supposed to start at. Now you got to prepare all the NICs for that VM so that we can actually start it. And for the network manager, then would talk to the network guru and says, well, this VM is started. Make sure all the resources are available. So here we would reserve VLANs, for example. If it was the first VM in that network to start, we would issue IP addresses if it was not issued at this point, because the network guru can decide it's not a static IP address. They want to be able to dynamically change the IP address. And that can be executed at that point. And once the network guru comes back and says, okay, here's all the information, then the network manager would talk to all the network elements in that network and says, look, this NIC is about to be started. Do whatever you need to do to make sure that this VM can participate in your services. You know, you can imagine a firewall I do firewall processes, and this network element would call its resources to make sure all the information is prepared for this for this particular VM. When that comes back, then the virtual machine manager then talks to the storage manager and says, now you need to be able to prepare your volumes. And storage manager would go check and says, well, this VM is using a particular template. I got to make sure that template is running on that particular primary storage. And the template manager may actually be making calls to its own resources and says, copy the template onto this primary storage if it's not already there. And finally, when that all has been done, then the virtual machine manager would make a call to a hypervisor resource and says, start the VM. And when that start the VM is done, then we will store the job results. And actually, at the end of this, we have events that gets fired to event listeners that says, oh, the VM has now been started, or and even before that, we would say, oh, the VM has that the VM is about to start, things like that. So if you don't want to be actually in the control path, and all you're interested is monitoring, you can actually monitor those type of events.
Hello, I have a question on the relationship between job ID and VM ID. Are they one-on-one mapping?
No, because you can start a VM multiple times. And in CloudStack, a VM is a persistent object. It's different from Amazon. And so a VM ID, so for example, when you start, let's say the very first job that was executed is the very first VM, then they both will have 1. But maybe the 10th time you started, that the job ID would be 10 and the VM ID would be 1. So they're two different things.
If something happens to the management server at some point through this process, what happens?
Yeah, that's a good question. And so for management server, all these things are inside the job. It's recorded in the job. So for today, what we do is inside the virtual machine manager, as it goes through each of these steps, it writes down the step that it is at. So it does basically a checkpoint. Right? And then if something failed, underneath in CloudStack, I think in this slide, I was showing cluster management. And so someone is responsible for notifying other nodes in this management cluster that this node has gone down. And someone will go back and roll back those operations.
Hello. Yeah, in that message flow diagram that you had over here, these 2 slides, roughly what is the latency it takes from the right to the beginning of saying, okay, deploy this VM to the time the actual VM gets deployed in terms of, is it seconds, minutes? And
That's a good question. And so let's say if I was running with a simulator, it would take seconds. And if I was talking with a physical resource, right, then it really depends on the physical resource itself. So for example, to start a VM in Sun server takes maybe about 10, 15 seconds. And to VMware, it might take a little bit longer. And it also depends on the work that needs to be done. For example, right here, actually right here, where we need to copy the template onto the primary storage, it's the very first time that template has been used and is available on that primary storage. The copying can take minutes, right? If it's a 10 gig, then it depends on your network speed before it finishes.
Now, I want to create like multiple VMs all with the same image. So I want to instantiate a whole bunch of things. Is there some stuff that you can kind of just optimize out or just do it once and there, when you're trying to do like a operation of trying to start up 100 VMs,
right?
Are there any optimizations you do in CloudStack?
Yeah, we let's say if it's 100 VMs for the same with the same template, then this template copy itself only happens once if it's to the same primary storage. Now, in terms of can CloudStack execute 100 VM starts, in our roadmap, we are actually doing something like the apps where you can say, I want to do 100 VMs off the same template. But today, you will orchestrate that outside of CloudStack in the script somewhere.
Yeah, I got a question about the storage allocator. Where is it here in the sequence flow?
Yeah, so right here in the deploy, I didn't want to draw it out because I got a little too detailed, and I really don't have enough components wide enough. But inside the deployment planner right here, once it decided this is the cluster that I want to place my VMs in, then it will go to the storage allocator and says, well, there's this many storage pools in this cluster. Select something for me to place. Yeah. I don't think it's on.
In the case where you order 100 VMs, is there a maximum rate at which, how many per second can you create? Is there a bottleneck? Let's say you're not copying the image because you already have the image.
Right. So then, and the determinant factor there would be how many requests total. That's it. Right? How many requests and how many threads available in the management server to do it. So you can increase more management servers, and we will actually be faster in terms of our management server speed. The actual response time depends on is a sum of all the resources executing its job. That we cannot do. But management server itself is scaled horizontally. Is there? Okay. Now, okay. So then we get to server resource. For our server resource, I kind of already talked about it being a translation layer between CloudStack and the resource API itself. It is communicated only in JSON, and everything is passed through like that. There's not an actual Java API call. And it may be co-located with the resource. And because it may be co-located with the resource, it has no access to the database. So the commands that are sent to it needs to contain everything and the resource needs to execute that particular command. Sorry, is there any questions about our server resources? And then there are DAOs, and I think there's actually quite a few confusions about our DAOs. We wrote our database, our own ORM, mainly because we don't want too much functionality in our own ORM area, because CloudStack actually is an execution engine, and it really needed a lot of direct access to the database. And at the same time, though, we do not want to have everyone write their own SQLs, because a lot of our guys actually are kernel developers, and they have no idea what SQL means. And so then, I'm serious. So then we write these DAOs that allows it. And the problem, the thing that caused confusion is that then a lot of people a lot of developers who were writing code that is above the kernel layer started thinking, oh, our DAO is our ORM for the entire product, and they started using it, and it's sufficiently good enough for people to use, but it's not really meant to be used that way. If you were writing things to do more scanning inside a CloudStack database, or get more information in a different way, or do monitoring in CloudStack, use your own ORM and figure out a different way to do it. It's not necessary to actually use the DAO. But if you were writing things for our kernel, then you really need to think about our DAO support. And I wanted to show it here so that people can see what can be done. And like I said, we have no support for complicated features for prefetch and things like that, if you're familiar with JPA. But we do use JPA annotations. And by the way, Hibernate has been ruled out because the licensing doesn't make sense. And so don't use Hibernate. Find a different ORM. And I'm open to suggestions, but that's a licensing issue. So for example, if you really wanted to add something and to CloudStack and CloudStack schema, and there's something that needs to be done inside the kernel, access inside the kernel, then this is an example of how you would add add a DAO into our system. Our standard Java entity being in with its annotations, and then you create a DAO that inherits from generic DAO interface, and then your implementation extends generic DAO base, and that's it. Because unless you're doing searching, if you're doing searching, then you have to write your own search queries. But if you're not doing any searching, then generic DAO base has all the code that does find by ID and things like that to retrieve those. And you don't actually have to write any of that code. And you don't have to write the SQL for that. Any questions? No. So actually, we're gonna. This is gonna be a part of the high availability portion. So it's 12:30. Okay. So we're gonna end the presentation on here. Any questions at all? Comments? Okay, I guess lunch is served, huh?
Outstanding. So, folks, if you exit this door here and walk